a world that increasingly relies on nuclear energy and technology, the question of what to do with radioactive waste stands paramount. Today, we're unraveling the mystery behind radioactive waste. What is it? Why is it a concern? And most importantly, how do we deal with it safely? Join us as we explore into the world of nuclear science and discover the measures taken to protect ourselves and our planet. First off, radioactive waste varies by its radioactivity level, from low-level waste like contaminated gloves and tools to high-level waste such as spent nuclear fuel. Handling radioactive waste begins with strict safety protocols. Workers wear protective gear and use specialized containers to prevent exposure. Radioactive waste is categorized based on its origin, physical and chemical properties, and specific activity level. Common categories include low-level waste, LW, intermediate-level waste, ILW, high-level waste, HLW, and very low-level waste, VLLW. Waste is segregated at the point of generation according to its category to facilitate appropriate treatment and disposal. This also includes separation of radioactive waste from non-radioactive waste to minimize the volume of waste that requires special handling. Waste is packed in containers that are appropriate for its category. Containers are designed to prevent leakage and shield radiation. For example, HLW often requires robust shielded casks. Treatment of radioactive waste. Techniques such as compaction, incineration, and evaporation are used to reduce the volume of waste, particularly for LLW and ILW, making it easier and safer to store and dispose of. Conditioning. This process involves immobilizing the waste in matrices like cement, bitumen, or glass. Conditioning stabilizes the waste and prevents the release of radioactive substances during storage, transportation, and disposal. Decontamination techniques is to remove or reduce the radioactivity on materials or equipment, potentially allowing them to be reused or disposed of as non-radioactive waste. Disposal of radioactive waste. Near-surface disposal, suitable for LW and some ILW. Waste is disposed of in engineered facilities located at or near the surface of the ground. Geological disposal, the preferred method for HLW and some types of ILW. Waste is placed in a deep geological repository, usually several hundred meters underground, in a stable geological environment where it is isolated from the biosphere. Transmutation. An emerging technology that involves changing the atomic structure of long-lived radioactive isotopes into isotopes that are either stable or have much shorter half-lives, thereby reducing the hazard and volume of HLW. Ocean disposal. Although practiced in the past, ocean disposal of radioactive waste is now banned under international agreements due to environmental concerns. Specific strategies. Regulatory compliance. All activities related to the handling, treatment, and disposal of radioactive waste must comply with national and international regulations to ensure safety and environmental protection. Safety measures. Implementing strict safety protocols during the handling, treatment, and disposal processes to protect workers, the public, and the environment. This includes monitoring and surveillance of waste disposal sites, public engagement and transparency, engaging with communities and stakeholders about radioactive waste management practices to build trust and understanding. Radioactive waste management is a complex field that requires advanced technology, rigorous safety standards, and careful planning to ensure the protection of human health and the environment. Continuous research and development are aimed at finding safer, more efficient, and more sustainable solutions for the long-term management of radioactive waste. Managing radioactive waste is a complex challenge, but with rigorous safety standards and continuous innovation, it's a challenge we're meeting head-on. As we advance, so do our methods, ensuring a safer future for all. Thanks for tuning in. If you found today's journey enlightening, give us a thumbs up, share this video, and subscribe for more fascinating dives into the science that shapes our world. Stay curious, stay safe, and see you in the next one.